We are going to start on chapter 4, which is titled Introduction to Organic Chemistry. Right. Now, just as a little bit of background on this, organic chemistry is concerned with organic compounds. Or sometimes we will say compounds of carbon. Compounds of carbon. Now, if you will remember from chapter 3, we established that carbon can form 4 bonds. Right? Consequence of that is that we can end up making carbon chains that just go on essentially as long as we want them to. Now, typically the organic compounds we deal with are going to at least have some hydrogens in them. So this would be a relatively simple carbon compound. My drawing it this way is key that we are going to have a hydrogen basically on every empty bond here, where we don't specify something else. Now, for our purposes, I'm going to give you this definition for an organic compound. Organic compounds contain at least one carbon-carbon bond and or one carbon-hydrogen bond. Right, so what do we mean by that? If I have this compound, this is an organic compound, carbon, hydrogen. This would be an organic compound because we have this carbon-carbon bond. This would not be an organic compound, but this would be, right? This one we don't have any carbon-carbon or carbon-hydrogen bonds. This one we do have this one carbon-hydrogen bond. Or of course, the vast majority of organic compounds that we look at are going to have some combination of both carbon-carbon and carbon-hydrogen bonds. But just making the point with that. All right. Now, in section 4.1, we're going to talk about representing the structure of organic compounds. Right. So we talk about organic compounds being compounds of carbon. So let's look at something. Let's say that we have 3 carbons bonded in a row here. Now, I'm going to mention this again, and I'm going to kind of emphasize it because this is key to understanding a lot of these structural representations that we're going to talk about. When we draw an organic compound, we're going to assume that any available bond on the carbon that's not explicitly shown as being bonded to something else is bonded to hydrogen. Now, what do I mean by any available bond? Here again, you'll remember from chapter 3, we talked about carbon forming 4 bonds anytime in this class. Not strictly true, but anytime in this class. So this carbon here, we only show it having 1 bond. So we can understand that this carbon is going to have 3 hydrogens on it. I'm getting a little ahead of myself. This carbon, we show 2 bonds on it. That leaves 2 bonds that we're going to have hydrogens on. This carbon, we only show it with 1 bond, so that's going to be 3. Let's go out a little larger. Let's go to, say, 5 carbons. Okay, this one, 1 bond, so we need 3 hydrogens. This one, 2 bonds, so we need 2 hydrogens. 2 bonds, 2 hydrogens. 2 bonds, 2 hydrogens. 1 bond, 3 hydrogens. Right. Or let's look at a little bit. Let's get a little bit more complicated with these structures. What if I have, let's say this. Okay, this carbon, we show 1 bond, so 3 hydrogens on it. This one, 1 bond, so 3 hydrogens. This one, 1 bond, so 3 hydrogens. This one, 3 bonds, so 1 hydrogen. This gets really, really tedious to draw. So we have a couple simplified ways that we can draw these structures. First of these is what we call, this, by the way, is what we call a full structure. So the next is the condensed structure. Now, for a condensed structure, what we say is that, okay, this is carbon bonded to 3 hydrogens. We're going to call this CH3. Carbon bonded to 2 hydrogens, this is going to be CH2. Carbon bonded to 3 hydrogens, this is going to be CH3. This one, CH3, then CH2, 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 and CH3. Right? But we could simplify this one down even more. We could condense it down even more, and we could call it CH3. All right, now for this one, I'm going to start off here in the center with the CH, then we have CH3, CH3, CH3. But this still gets a little bit bulky to do. And so we have this other technique of representing structures called the line, or called the skeletal structure. That's the term your book uses. And this compound, here's how we show a skeletal structure of this compound. We show it like that, right? Now, here's what this means. In a skeletal structure, any end or any bend represents a carbon. Ends and bends are carbons. So carbon here, carbon here, carbon here. We understand, because we only show 1 bond to carbon here, that we have 3 hydrogens on this. We understand, because we show 2 bonds here, that we have 2 hydrogens. Understand, because we show 1 bond, that we have 3 hydrogens. All right. This one. 1, 2, 3, 4. 1, 2, 3, 4. I came up 1 short, 5. Now for this one, it would be something like that. Or if we want to pretty up those angles a little bit, we could do it like that. Right? So that's how that works.